Why, hello there. Welcome back. This is episode 3, I think, of my build log of the Trumpeter 1 to 200 scale model Titanic. In this episode, I'm going to talk through how I fitted the propeller shafts, and this was a real challenge actually. All of the jobs I've done on this model so far, they've all been challenging, but most of the jobs so far have been repetitive. The real challenge has been not making a mistake when you're drilling 800 portholes. With this one, it was just accuracy. So much accuracy was required to get the prop shafts in the way I wanted them. I'm particularly conscious, because this is an actual radio control model boat. If the prop shafts aren't in straight and stuff, the wash from the stern of the ship is going to look rubbish. It might not even sail straight. So there's quite a lot of pressure on this to get it right. So with that in mind, I do have one small apology. A lot of the work here was really sort of fiddly, and so a lot of the time I either haven't been able to film it or the film's just been rubbish because all you see is the back of my head. So some of the time I am just going to be talking over still images. So sorry about that, but hopefully it is still of some use to you. So without any further ado, I will crack on.
So these are the shafts I'm going to use. They're made by a company called Caldercraft in the UK, and I've bought two sizes. I bought an 8-inch shaft for the central propeller and a 9-inch shaft for the two wing propellers. The reason for this is because I like to mount my motors on flat parts of hulls, and the reason for this is I think if you can mount a motor on a flat portion of hull, it gives a much more secure mount for the motor. It helps to reduce things like vibrations down to an absolute minimum, and certainly with a ship like Titanic, an ocean liner, I really don't want it to have loud vibrations when it's sailing around a pond. The actual propeller shafts themselves, the shaft is a 4mm with an M4 thread on each end, and the mounting is 6mm outside diameter. These were the thinnest arrangements I could find with a 4mm shaft. The reason I wanted a 4mm shaft is because the Pontos upgrade kit comes with these really nice brass cast propellers, and any smaller type of shaft wouldn't really be compatible. But a 4mm shaft, I'm going to be able to drill out, I don't know if you can quite see it, I'm going to be able to drill out this hole and tap it M4, which means I can use these props on the actual model. The mounting is 6mm, and this is almost exactly right for the wing propeller mounts. The mounts that the kit comes with are, I think I measured them at about 7.5mm, which means that this mounting can just fit inside those wing mounts, which gives you a really nice, elegant finish to the model. So this is now the first of the still images. The first job that I did was to chop off the mounting stem, which has brackets for the rudder, and the reason I had to do this was because it was the only way I could gain access to drill out the central propeller. When I come to remount this stem, I'm actually going to drill it and insert a very, very fine brass bar, and also glue it, which is going to give me a mechanical and a chemical bond, which I think will be sufficient to hold it in place. Once I had access to the central propeller shaft, the first thing I did was to centre drill it with a 1mm drill bit. It was at this point that it really sort of strikes you how one little mistake will take a huge amount of time to repair. So the real moral of the story here is take your time, take your time. After the 1mm drill bit, I slowly opened out the hole with a 2mm bit, then a 4, and finally with a 6mm drill bit. And this left me with a hole which was sufficient to mount the central propeller shafts like this. It's worth saying that I haven't glued in the central propeller shaft at this point. I actually have deliberately left it loose because I'm going to glue all three shafts together in one go to make sure that they're all perfectly aligned.
The next job is to sort out the wing propeller mounting. As far as I can tell, there are two different ways of doing this, and both sort of require different, fairly fiddly operations. When I come up with these kind of situations where there's a few different ways of doing things, I tend to draw stuff up on a CAD system because I tend to find that it allows you to sort of see how components fit together much more accurately than you could ever picture in your head. And I tend to find that I spot things that I wouldn't otherwise have realised before having to actually make any cuts in material or anything like that. So quite often it can save you making a mistake and then having to go back and fix something later on. I tend to use Fusion 360, which is it's quite a good CAD system actually. I'm not affiliated with them or anything like that, but it's free for hobbyists, which is obviously quite attractive to me. It's pretty intuitive to use, and it comes up with some pretty good results. So that's the CAD system I tend to use. To show you the two different ideas that I've come up with for the propeller system, I've made a couple of quick animations, and I'll just talk through how these are going to work and the sort of the pros and cons of each one. With option 1, I'm going to remove a portion of the brass shroud which comes with the propeller shaft, and also with this remove one of the bearing caps from the end. This will give me a propeller shaft which is half exposed, half not. In the plastic wing propeller mount, I will cut a 6mm hole about 5mm deep, and this allows me to mount the bearing, which I removed, and it will allow me to run the propeller shaft through this plastic component without any assistance from the brass shroud. The idea here being that the brass shroud will come out of the hull and then stop, and the propeller shaft will run unassisted up until the bearing, which I've embedded in the plastic component at the end. The second option is to keep the propeller shaft exactly as is, so keep it as one whole component. And what I'll intend to do here instead is to cut a 6mm hole all the way through the plastic wing propeller mount, as you can see here. This will allow me to mount the entirety of the propeller shaft in this plastic component, like so, which then allows me to run the propeller shaft directly through the hull all the way out the plastic component until the propeller itself. So the main positive with option 1 is that I don't have to do very much to the plastic component. In fact, all I actually have to do is cut a 6mm hole about 5mm deep to allow it to accept the bearing at the end of the propeller shaft. There are, however, quite a few downsides. The first downside is that because the propeller shaft isn't completely sheathed in the brass tube, any lubrication that I put on this shaft is going to get washed away very quickly by water flowing over it. And this means that I'm going to have to re-lubricate the shafts very regularly. It's probably going to have to be pretty much every time the boat gets run. The other issue is that I don't think it's going to be as structurally sound a design. And the problem with this is, because I've removed quite a large portion of the brass shroud, the only real structural integrity for the propeller shaft outside of the hull comes from the plastic component, and I'm a bit worried that any time this gets knocked or bumped, it's going to put both of the brass bearings out of alignment, and this is going to, it's going to create additional friction for the motors, which means they're going to have to work harder, they're going to use additional power. It increases the chance of the motors burning out quicker, and the bearings are going to wear quicker. So, although this design is perhaps simpler, I think there are some inherent problems with it, which makes it slightly less practical than option 2. So my major concern with option 2 is having to drill the 6mm hole all the way through the plastic component. And my concern here is that having drilled a 6mm hole, there's not going to be very much material left around the propeller shaft. And whilst that's not really an issue structurally, the problem, my concern is if the drilling process is going to actually damage the component. On the plus side though, I think this design will be much more sound structurally. I think it'll be much more resilient to knocks and bumps, and I also think in terms of things like lubrication, it's going to do a much better job. So this is the idea that I'm going to go with. Because of my concern over damaging the component while drilling, I bound it very tightly in sellotape to support the outside, and I also clamped it in a vise during the drilling process. And as you can see, this allowed me to do a really quite nice drill hole directly through the plastic component. Unfortunately, the drill bit wasn't quite long enough to go through the entire piece of plastic, so I had to finish off the cut with some microfiles, which in reality probably wasn't a bad thing, as it gave me a lot more control over the material I was cutting away. Once I was done, I was then able to mount the propeller shafts inside these plastic parts, and I glued them in place with superglue,
or cyanoacrylate adhesive, I think it's called.
Sadly, that wasn't actually the hardest part of the job. The hardest part was getting the holes cut in the hull. So I started out by drilling out 3 holes just with a simple drill. I then opened out these holes with a microfile. The real challenge, though, was getting the holes shaped to allow me to run the prop shafts absolutely parallel with the keel of the ship. I had to take a lot of material out the sides of the holes. There was a lot of, cutting, measuring, cutting again, remeasuring, cutting before I actually had holes that I was happy with. But, slow and steady did it in the end, and once I had the holes, I used some blue tack to hold the prop shaft in place while I glued the plastic parts on the outside of the hull. Here I'm using Tamiya extra thin glue. It's actually really good stuff. I really like it. It's miles better than those old rubbish tubes of glue you used to get years ago, where you either squeeze and get no glue, or you squeeze and get about 40 gallons of glue pouring all over your model. Using the blue tack here was a really, really nice idea, actually, because it allowed me to sort of fine-tune and just sort of tweak the propeller shafts to get them in exactly the position I wanted them before actually gluing. You can see as well here the stress marks on the plastic from the drilling process, so I am really glad that I used a vise and the sellotape to support the parts during that. It's worth saying that they haven't actually been misshapen, it's just that the actual plastic has been stressed, so once the model's all painted up, you aren't going to be able to see any of the effects of this. Once the parts had dried, I removed the blue tack from the inside of the hull and used fairly liberal amounts of epoxy to seal the shafts in place to make sure there was no water ingress. I then went round the outside joints with an epoxy filler just to make sure that there were no sort of open seams or anything like that, which would spoil the effect of the model. I had hoped to show the epoxying process in this video, but I'm just conscious it's getting a bit long now, so I think it might be a better idea just to hold that back until the next video. But yeah, I'm quite relieved really. This was a tough job that had to be done well, so I'm pleased it's gone as well as it has. I've got to say, one of the things I really like about this model is every so often you get a sort of a flash of one of the famous images of the Olympic class liners. So this one for me, it looks quite reminiscent of the photo of the Olympics propellers with the lads from Harland and Wolff standing round, and it just gives you that sense of scale. Anyway, video's getting a bit long now, so I'll call it a day there. Thanks very much for watching. If you've got any questions or anything, leave them down below. If you've liked this, please think about giving us a like or maybe even subscribing to the channel, and I will see you in the next one. Bye for now.